All right, we're going to go ahead and get started. Welcome everyone to our webinar. Very happy to have you here. We're going to be talking about our product Restructured and this idea of using generative AI to transform unstructured data into actionable insights. It's going to be a pretty exciting topic. I'm sure a lot of you are familiar with the challenges of dealing with unstructured data and are very curious about how you can maximize the value you're going to get out of it. We're very excited to show off what we've built for you. I've got Dylan here with me, staff engineer here at Kolena. He's going to be taking over and giving the demo after I do a little bit of intro. And yeah, towards the end, we're going to have Q&A. So as you are watching the webinar, if you have questions, please use the Q&A widget here in the Zoom webinar, and we will answer some of your questions live at the end of the talk. So keep that in mind. Before we get into the meat of the presentation here, I just want to say a quick word about Kolena. I've got this slide here. We hosted our first conference just over the summer here called AIQCon, really centralized around the theme for Kolena, which is AI quality, building quality AI models and products, and building gold standards for evaluating AI and ML applications. We have a lot of the talks up on YouTube now, so if you're curious about some of the talks that were shared at the conference, lots of technical talks, lots of thought leadership talks, policy talks, all kinds of things. We had some great technology partners and regulatory partners and media. And so definitely go check out, just search for AIQCon on YouTube, or you can go to Kolena's channel as well. Lots of good content there. Cool. All right, here's our agenda for today. We're going to start off with talking about this problem of extracting value from unstructured data, the promise of all of this information that's in that unstructured data, and then the problem of actually making use of it without having structure. Then we'll get into how LLMs have really changed the game here. Using LLMs to transform data, there are paradigms before and after LLMs, essentially, that's really enabled a lot of things that previous processes weren't feasible for some of the real-time and high-volume use cases that we have today. Then we're going to show you Restructured. Dylan will take over for that part. Restructured is our comprehensive solution to transforming large volumes of complex unstructured data into actionable insights. Very excited to show that off for you. We're going to have a couple of product demonstrations, and then we'll wrap up with Q&A. And again, keep in mind, if you have questions as you're watching, like, can it do this? Or how did you implement this? Or what technology is underlying? Things like that, feel free to post those in the Q&A. We won't answer them during the presentation, but we'll come back to all of those and answer them at the end with Dylan. All right, let's go ahead and get started. So just starting off with a brief introduction to this idea of extracting value from unstructured data. Quick definition for anybody that by chance isn't familiar. Unstructured data is just information that doesn't have a predefined data model, and that includes things that you might think of as kind of structured but are not considered structured data. Things like documents, PDFs, for example, emails, images, audio, video. These are all considered unstructured because they don't have this data schema that can be used in a structured way, in the way that we think of data processing anyway. There's a wealth of insights in unstructured data, though. Like a vast majority of the data that we're dealing with on a day-to-day basis is actually unstructured, and it often has to be structured in order to be used. But it's just been incredibly difficult to extract and utilize in real time because of several limitations, which I'm going to go into now. So the main challenges here, organizations face three major challenges when it comes to unstructured data. The first one being volume. There's just a lot of it. The sheer amount of data generated and collected can be pretty staggering. And manual review at that scale just isn't feasible. So you have to have some automation built in. But then there's also the problem of variety. You have data exists in all different kinds of formats, PDF scanned images, etc. There also data is living in different silos. Where this data lives is not all necessarily in the same place. So unifying all of that can make it difficult. And if you're doing a manual traditional process, that means you have to have you often have to have a different pipeline for each type of data that you're working with. And the last one is velocity. Business decisions obviously are ideally made as quickly as possible, and it can be a real problem to wait for delays caused by laborious data processing and analysis. Can't wait for manual review, can't wait for a slow multi-step process if you are trying to make decisions in real time. And so these three, volume, variety, and velocity, are really the main challenges in terms of getting the most value out of unstructured data. And in order to be maximally utilized, you want to transform this unstructured data into a format that's more readily consumable by the downstream processes, so you can continue to automate, drive towards those business decisions in real time, and such as creating a tabular data format that lots of tools are able to use that structured data format. And in terms of just simple data analysis, it also makes it a lot easier for you as a user to understand what you're working with as well. So up to now, these are some of the ways that people have extracted structure or created structure from unstructured data without generative AI, without LLMs. Obviously, manual data entry has been a big one, but it's slow, very labor intensive, of course, prone to human error. It doesn't really work for large volumes. OCR, this is technology that's been around for a while, but it can be a bit particular, and it doesn't necessarily have a larger sense of, it doesn't go beyond that part of the process. It's just a narrow step, but still very common here. NLP algorithms have also been around for a long time, things like entity extraction, so extracting a noun, for example. Still very practical and useful, but it, again, doesn't have any contextual understanding. So you're just getting those things in isolation. And then rule-based systems. So you might have a rule-based system that uses all of these as different components, or knows a particular data format that you're working with and can use rules to extract those things. But you really have to be constantly maintaining those, and they don't adapt very well to new formats that come in. If something about the structure of the documents that you're using changes, then your rule-based system has to be updated manually to deal with that usually. Now, to contrast that with LLMs, the game's really changed quite a bit. So it's doing things in real time, especially, is just a lot more feasible. The first one is that with these large language models, you have contextual understanding. So they are coming at it from a human-like perspective, in a sense. They have the meaning and the context as part of what they are using to help organize the information. And they can understand things like jargon based on whatever use case is, without necessarily having to have those things hard-coded. Continue with that, they are adaptable. So unlike those rule-based systems that I was mentioning, they can be really flexible. They learn from diverse data, and you can tune them relatively easily compared to a rule-based system. And very importantly, scalability. So they can handle vast, complex data sets. Like I said, there's a huge amount of unstructured data. Most of it doesn't get used for its full information because there's so much of it, and processing was slow. But with LLMs, they're very good at this. They're very good at taking in very large contexts and generating results in near real time, basically. So you can start to do analysis in real time. You can start to make business decisions in real time and start to automate a lot of the things that you couldn't before. So in order to talk about that, I'm going to hand it over to Dylan. He is one of our staff engineers here at Kolena. He's got a lot of experience thinking about these AI problems. And I'm going to go ahead and stop my share here and hand it over to Dylan. Dylan, we're very happy to have you.
All righty. Thank you, Skip. My screen's coming through okay?
Yes, sir.
Great. So nice to meet everyone. My name is Dylan. I'm one of the staff engineers here at Kolena. I've had sort of a meandering career, but the common thread through it has been sort of sitting at this intersection between applying different hard sciences to intuitive products, usually using some kind of web technology. But last 4 years or so, it's been in the machine learning space. Prior to that, in geoscience and healthcare. And if there's any science nerds listening to the talk, as a physicist in the beginning of my career, I worked on a few interesting projects, including the Ice Cube experiment, which is a particle detector that's actually buried in the Antarctic ice at the South Pole, and basically is a telescope, but with particles analyzing the universe. Very cool project. But to bring it back to planet Earth, going to do a quick demo of the product we're going to showcase. And after the short demo, I'll kind of step back, talk about the bigger context and our thinking behind it and how it works. And then I'll resume sort of a longer demo of how the product works. And so, yeah, the idea here is basically, can I take a mess of data and extract insights from it using LLMs? And the philosophy here is that we think that this technology is very useful in specific applications. And the idea behind this product is trying to distill where that technology works really well and for what real use cases it might work well. So I'm going to stop the slides and jump into the actual application. So this is my initial view. Basically, what we're looking at here is a collection of documents that I have on hand. And this is kind of a mismatch. There's a few documents in here that are well-formed sort of PDFs of invoices. There's a few scanned receipts. There's pictures of receipts. So this is like a PNG of an invoice. And then there's also really complicated cases, like I've got a handwritten contract from selling my car. And even though all this data is not really structured the same, there is some commonality in the data. And in this case, I want to perform like some very simple analysis from the data, starting just with the raw documents and using LLMs to get there. So from this view of my folder of data, our restructured platform will take the contents of your data, analyze it, and suggest different data you might want to extract from the documents that'll be useful to you. So that's what we're seeing at the bottom here. And I'm going to go ahead and just click on a few of these and extract some data for a simple example. So this is a collection of miscellaneous data, but it all is sort of related to expenditures. So there's dates and payment amounts attached to all of this data. So I'm just going to go ahead and click on date, as well as the total amount. And Restructured will now take the documents, parse them using LLMs, and give me a structured table of data that I can work with. So this is just completed now. And basically in a few seconds, I've taken this folder of data and basically turned it into a database. So I have some structured data I can now do different advanced queries with. In addition, we try to provide some traceability into how it extracted that information. So if I hover over the values here, I can actually see within the content of the document where it pulled that information from. And if we scroll down to the more complicated cases as well, even for this handwritten contract, you can see it's extracted the due amount and date from this handwritten document. Now that we have the data actually extracted, there's a whole bunch of other analysis that we can do, again, powered by LLMs. So as a very simple teaser example, let's just ask Restructured to plot the running total spent over time. And in this case, Restructured is going to interpret my instruction to actually generate code to generate a plot. And I should now see a running total of expenses over time. And you can see the contract for the car is right here. And this is, there's some hypothetical data here with future dates, but it's, generated this plot successfully for me. Jumping back to some slides here. I guess I should address maybe a few kind of elephants in the room, or anticipate questions I feel like people will have about the application of GenAI and its usefulness for real work. I feel like, we've had this technology for 2 years-ish now. I think the novelty's kind of worn off for people. People are kind of tired of seeing chat apps everywhere. And I think the technology is kind of at a phase where it needs to sort of move it or lose it. It's got to find real applications or it's going to kind of fade away. And I'm sure people have seen this kind of curve before of new technologies where, something magical comes out, the expectations get blown out of proportion, then it kind of comes back to reality. And hopefully it finds some plateau where it finds actual real uses. But I guess one thing I want to flag is, for a lot of cases, a lot of use cases and applications of this technology, it won't find that plateau. It'll just go away because it doesn't make sense for, specific use cases. So, like two examples, I have an Android phone, and when I go to send a message, the very top thing on it is to chat with Google's chat model. I don't know why I would want to do that if my intention was to, message my wife about something. Likewise, in the software we use for internal wikis, there's sort of spam everywhere about using LLMs to generate content, which I find very odd, considering, this software is specifically for me to capture human knowledge that's specific to my team that an LLM couldn't possibly know. So our idea with, Restructured is basically how can we find the specific use cases for this for real work that actually work decent enough to, make a difference in your day-to-day work for knowledge workers. Another, elephant in the room should address is, these models are pretty powerful, and the chat applications that the model providers are getting better and better. So why do we need anything to like wrap functionality for these models? And I guess I would rephrase the question, if we were thinking of this, 10 years ago or something, why do you need a Python wrapper application? Why don't you just, do the thing you want to do in code? It's already a technology that exists, right? And I think just fundamentally in both cases, even though one might be more powerful than the other, in some cases, they're both fundamentally just technologies that unlock capability. And the model providers, their number one priority is making the best possible models. Their number one focus is never going to be helping you in your unique task, making you more productive. That being said, at the end of this talk, if your takeaway is basically, I find these techniques interesting, I'm going to apply them to my own work. I don't need another application to do this. I'm going to do it myself. It's worth maybe going into a little bit of the complexity that we encountered developing this product and what we think the product helps solve. So, as a general kind of diagram of what happens, you kind of start with your unstructured data, which could be anything. It could be, video data or images or transcripts, et cetera. And maybe the real outcome you're looking to get with this technology is like a suggested decision or something to help you reach that decision. Maybe you want to create content or provide a structured output so you can do something else, like take data, map it to a data table or a database that you can use for another purpose. Sort of on the left side of the flow here, some of the complexities that we run into is it's very hard to know how arbitrary data maps to each other. It's also very hard to find the right representation for that data that these models will understand well. So even something simple like parsing out document content, we find for a lot of libraries or models, they're very good at extracting text. And then for some reason, you go to extract the state of a checkbox, and it can tell that there's a checkbox in a document, but it completely fails to get the right state of the checkbox, which kind of makes the entire extraction fail. So there's this whole complexity around, for what kinds of data is the right model applied. It's not a one size fit all solution. There's no product like that on the market. You have to have that knowledge to sort of route your data to the right extractions. On the right-hand side of this diagram, a lot of the complexity is, dealing with the limitation of these models. They're very impressive, but they still have limitations. For instance, there's a large amount of data they can process, but it's still limited. And so you have to have clever techniques to determine, basically distill your data down to something a model can deal with. And that might involve taking a very complicated workflow and sort of breaking it down into small steps. And additionally, you have to have like some data normalization and consistency as you're going through these steps. Otherwise, important detail and accuracy is lost. And, maybe one of the trickiest things about this whole thing is like, how do you build something that's transparent so you can go from a decision back to your original data and sort of have that audit trail and understand if a suggestion is valid and have like some human in the loop feedback for whether that's valid. So on the topic of dealing with this, the limitations of these models, there is lots to be optimistic of. So I think especially the last, let's say, 3 to 5 months, we've seen a lot of interesting parts of this technology come to fruition, and it's making a lot of production use cases possible. So some things that have emerged over the last few months is these models are kind of modified now. There's a lot of providers making them. They're all generally very high quality. There's the OpenAIs and Googles and Anthropics, et cetera. There's also a ton of very powerful open source models available now. And that includes models that, I can run on my own laptop that I don't need to pay any of these providers for. There's sort of no moat. And there's a lot of different deployment options where I might not even need to send my data to the cloud at all to run something useful with these models. So they're quite capable. Maybe there'll be a plateau they reach with this technology, but so far progress is still being made. A lot of cases, they can be powerful enough to basically fool us into thinking they're humans. They're very cheap now. OpenAI, for instance, released their sort of mini models. There's the open source ones that you can run on your own infrastructure. But even for like the cloud hosted versions, you can take a literal Russian novel of text. You could take War and Peace and process that input output with a model, and it can cost under $1 now, which is pretty incredible. And these models are also becoming long context by default. So a lot of these models can handle over 100,000 tokens, which, for a relative size, that's, maybe like 20% of the novel War and Peace that can be processed in one go. In addition, there's sort of a plethora of open source multimodal models that can handle image, video, text data. And in addition, there's lots of functionality coming out for models being able to have sort of predictable outputs, which is important for building these sort of flows, these, quote, agentic flows, where you might take a complex workflow that these models can't do well, but then break it down into smaller pieces, which they can do well. And that sort of breaking it down to smaller pieces is part of the philosophy behind Restructured, where, a lot of times there's specific data you want to get out, and that might be for an end goal, but the process of extracting that data in itself can be valuable because the byproduct is you basically got, structured data as a table as a result of doing that. So with that, let me jump into a more extended example. So just to set this up a little bit, the flow we're going to be looking at is basically, I'm going to pretend that I'm a customer support manager and I've got a collection of data, and the data represents call transcripts between my agents and my customers. So let's go ahead and just import that into Restructured. So I'm going to select this file of text content. And if we look at the individual data points here, basically I've got short transcripts between an agent and customer. And they might exchange some basic information, go through an issue they're trying to resolve. And maybe it gets resolved, maybe it doesn't, maybe it's escalated or not. But there's enough data here that I can do some analysis on my team's performance and what's causing pain points for our customers. And are they leaving with a negative impression of the company? What's the general status and health of this team and how they're relating with our customer base? So to get started with that analysis, let's go ahead and extract some data from this text. So I've got these 250 calls. I'm going to do an extraction on the content of these calls. And the first thing I'm going to do is just get a very short summary. So I'm going to ask Restructured to just get a one-sentence summary of the call. Now, before I extract on all 250 data points, I can also preview what the extraction is going to look like as a validation step. And I can see here, this based on the text that's behind here, this looks like a pretty accurate representation of the call. So I'm going to go ahead and extract that. And this will now run for all 250 data points. This could be 2,000 or 20,000 for that matter. Just have a small example for the purpose of this demo. But this is real-time extractions happening. So now with these short summaries, I want to basically categorize the types of issues that are captured here, because I kind of want to know, what's actually causing issues for my team. and how am I going to improve it? But I don't really want to look through all this data. But this is something that LLM is very good at. So I'm just going to ask the LLM to categorize these issues into a small number of categories. I'll let the LLM decide how many it should. And then I'm going to ask it to just give me back a comma separated list. Okay, and it's given me some suggestions for categorization here. So I'm going to go ahead and just copy this data here, and I'm actually going to apply that categorization. So on the conversation content itself, I'm going to classify this, and I'm going to call this issue type, and I'm just going to drop in my list of issue types. And now if I apply this, it'll go through and basically classify the best sort of description of each call. Let's see. I'll also get a few other pieces of information here. So, something basic. I might just want to know the name of the agent involved. So maybe I can see if there's like particular issues with certain agents on the team. So I'll go ahead and extract that as well. Just get the agent name. And there's a few sort of Boolean values I want to extract for the purposes of analysis. So I want to know whether an issue was escalated and also whether it was resolved. So I'm going to go ahead and do those. And based on the phrasing of the extraction, Restructured will interpret the correct response type and make sure that it's consistent in the extraction. So for escalated, I'm going to ask it to get whether the issue was escalated. Run this. And I'm also going to likewise check for the resolve status and get whether the issue was resolved on the call. And I'll run that extraction as well. Maybe final simple extraction I might want to do is just classify the general sentiment of the customer based on the conversation here. So I'll do that as a classification as well. And I'll just generally group it into they had a positive, negative, or neutral experience. And I might provide some instructions just so it's clear what the meaning of this here is. So I'll say, get the sentiment of the customer towards the agent and company, and run that classification as well. So I've taken just a set of transcripts, and I've got a pretty decent collection of structured data that I can now export if I want for other purposes, or I can do some analysis inside the app here. So let's go ahead and start doing that. So one thing I might want to know is what issue types are being escalated, or which issue types are just being reported more. So I can ask for plot the distribution of issue types in a pie chart. And Restructured will interpret this as I want to plot. It'll generate the code, which I can inspect, and generate the final plot. So I can see delivery and exchange and returns are sort of coming up as persistent issues. Likewise, I can ask it to show the number of escalated issues by type. So I can just see as a raw count, which issues are causing our agents to spend the most time on. So it looks like these two are also actually escalated the most often as well. In addition, I could, for a specific agent, maybe see how this is being handled by them. So as sort of my baseline, maybe I can ask for plot the distribution of customer sentiment. And then after I have that data, I can compare for a specific agent to get kind of a comparison. So this is my distribution. I can save it off for analysis later. And this is available to me so I can make some public dashboards, and these will update as I put new data into our system. But with that saved, let me go grab that and say for agent, or let's say for issues handled by agent Sarah. Okay, and from this baseline, this agent is actually really in line with the average sentiment. So my impression is that they're not. There's no outlier here for how they're handling calls and the sentiment that customers are leaving with. As a final example that's more complex, I'm going to copy this prompt in just because it's a bit longer, and then walk through it. But basically, going to ask, you're the head. Pretend Restructured, you're the head of customer support. You're me, basically. Analyze the data in this table provided, and I want to have a detailed report outputted to me that I can show to my leadership team. And I want to focus on the status of the support tickets and basically my team's performance in handling these tickets. And I want to include KPIs that I've captured in the structured table below. So if I execute that query, I should now have Restructured start to generate natural language response for me. That's going to get this template for reports, but also insert real data from this table. So I've got the total number of tickets handled, the resolution rate on the call, as well as escalation. So basically focusing on what I've identified as important to me for my data. In addition, I've got some detailed analysis, but also some next steps for areas of improvement that I can focus on to improve my metrics. So it seems like a lot of cases are not being resolved at the first level. So there's probably training that needs to happen on returns and delivery type issues. So this is basically taking in this case text data, give me some structured output that I can work with, and I might have some real outputs that I can have update with real data live, but I've also got now a database started that kind of defines the schema of my problem. So with that, there's other demos we can go into as part of the Q&A, but with that, I'll hand this off back to Skip for now.
Thank you very much, Dylan. I'm going to go ahead and pop up a slide real quick here. Right. Cool. Yeah. So Dylan just showed you Restructured. This is our AI-powered knowledge management platform. And I want to kind of recap what Dylan has shown here in terms of what the product is. While I'm doing that, if you have your questions, please drop those in. We're going to get to the Q&A in just a couple of minutes here. So whatever questions you have about your own use case or what the functionality is for what Dylan has showed you, what else you can do, any questions, please drop those into the Q&A widget here in the Zoom. We'll get to that in just a minute. I wanted to mention, though, here's just some example use cases. So if you're trying to think about how you might apply this to your own domain, I just wanted to list just some examples for different industries. So certainly for finance, there's a ton of unstructured data, a lot of documents to deal with, and it has to be analyzed to make decisions. And this tool is really very powerful for extracting data to make those decisions much faster. Risk assessment and compliance-related document analysis, everything that involves looking at these big policy documents, legal, very related. So accelerating legal research, case preparation, contract review and analysis. Consulting, similarly, so speeding up strategic recommendations, again, getting back to this fast decision-making by automating data extraction and analysis. Life sciences and pharmaceuticals. So research in general, this is a very powerful tool for research in general. Obviously, compliance, again, enhancing drug discovery, clinical trial data analysis. Energy and utilities is a different one. So again, automating data extraction, in this case, it's more to improve operational efficiency, doing things as well as possible. And again, coming back to compliance, compliance is always going to be important. It's always going to be new regulations and new compliance requirements that you're going to need to be able to deal with. And this tool makes it much simpler and a lot easier to handle at scale. And these are just a few examples of some industries, but really any domain with large volumes of unstructured data, this is a great tool for it. Yeah, if there's a particular domain that you're wondering about, please ask us in the Q&A. We'd love to chat with you. Some feature highlights. So the tool that we were just showing here, these are kind of the things that I think are the most important things to mention here. First, most important one, of course, is that it's comprehensive data analysis. It's capable of processing all kinds of different data formats simultaneously: PDFs, slides, images, emails, audio, video. It's basically an infinite context window, so extensive volumes of data. If you're an enterprise with vast documentation, vast document sets, then this tool is going to be very useful for you. Actionable intelligence. So we're really driving at information and insights that are actionable, so you can actually make business decisions. You're breaking down complex queries into manageable tasks, and getting accurate results with them. Transparency and traceability. We're just talking about compliance quite a bit here. One of the neat features of this tool is that it's going to provide citations for every action, so that you can demonstrate how all of your business decision making was reached. And then, of course, we're in the age of AI here, and Restructured is no stranger to that. Adaptability and learning is one of the coolest features here. So it's designed to improve over time. So it learns from past actions and processes conducted by users, and it can be taught how you or your organization makes decisions. So to kind of tie this up in a bow before we get to the Q&A, this is kind of the summary for what Restructured is. It's really supposed to be a comprehensive solution for enterprises to leverage AI for information analysis and knowledge work. It transforms large volumes of complex unstructured data into actionable insights. It enables you to extract, organize, and compare detailed information from different types of documents and unstructured data. Provides answers in this structured spreadsheet-like format for easy analysis, and for downstream use by other tools that are expecting that format in particular. And in that vein, really, it's getting your data AI ready. So being able to take advantage of all of the cool new AI technologies that are out there because your data is in the right format. And we built Restructured to be AI that works the way that you work. So no question is too complex, no amount of data is too much, and the responses are not a black box. We really are supporting you in the way that you work as much as possible, and that's part of our design philosophy here. So if you are curious about giving Restructured a try, we have you can either email us at restructured@Kolena. This is a link. I realize you can't click it. So there's a QR code, and I'm actually going to drop that into the chat right now. If you are curious about it, let me pull that up. There we go. That's a sign-up form if you're interested in a beta. We would love to work with you. If you're wondering if it'll work on your particular data, your use case, just contact us, and we'd be very happy to chat with you about it. Right. All right, so we're going to go ahead and move to the Q&A portion here. Let me go ahead and bring that up now. Okay. All right, first question, Dylan, for you is going to be a softball. Do you like the three-body problem?
I have to admit, I'm pretty behind on streaming shows. Been watching the box set of The Sopranos, so afraid I can't answer that one one way or the other.
I think that was in response to your science background. It's very physics heavy. I'm a fan for sure. Cool. All right, we'll move on to something with substance here. Gideon asks, would you recommend to load the restructured data from an unstructured source into a data warehouse or a data lake?
Yeah, great question. So the idea behind this tool is sort of flexible input and output. So you could really load from a database table if you wanted to. The idea is you should be able to connect to kind of any data source, any data type, any data source is the ultimate goal here. In terms of storage and putting this into pipelines and stuff like that, we do have a Python client available, with the idea being that you might use the web application to sort of decide what extractions are most useful for you, and then you can codify that into a pipeline by running your Python code with those extractions and storing it wherever makes sense, whether that's a database or a warehouse or anything like that.
Yeah, we have a related question here from Chris Berry. He asks, what happens regarding storage of our unstructured data? We deal with patient health information, so HIPAA compliance is a necessity.
Yeah, so there's a link, maybe we should drop in the channel, trust.kolena.com, that kind of goes through different compliances that Kolena adheres to. So yeah, in terms of retaining the data. We're HIPAA compliant with data retention. We do offer the ability to run this on-prem if needed. And there's sort of a range of deployment options where you could opt to, you could use models that only run locally that don't send any data externally. The performance will be obviously better if you use state-of-the-art models, but that's sort of the range of deployment options that we have on offer. And yeah, in terms of data retention, so any raw data that you put in, we don't do any model training. If you do use a cloud-hosted version, all the data is encrypted at storage and in transit.
Great. Question from Fernando. He says, what is the precision here, let's say in sentiment analysis?
Yes, great question. Difficult to answer concretely just because it'll depend so much on the data. I know that's such a compound answer, but we do have benchmarks that we can share for concrete numbers on sort of known data sets. But in general, it's going to of course depend on your data. And something we didn't show off, but we are building is basically feedback mechanism so that you can apply a classification, review a very small number of those samples, and then with the feedback of a correction or not, use that to reinforce a classifier model to rerun with higher precision.
Another question from Chris. He asks, can you manually adjust information that may have been extracted inaccurately?
Yeah, I just touched on that, and it'll so with the short answer is yes, and also with the active the manual corrections, you can choose to opt into a feature where we will use those corrections as positive or negative examples to improve the classification to allow you to rerun with a custom classifier.
Another question that you've already touched on, but just to reiterate here, does the app retain the data for future AI model trainings? And they are worried about confidential data in particular.
Yeah, so yeah, reaffirm that we don't do any model training on the raw data, or extracted like text data for that matter. We have a number of healthcare customers on. We have customers on this product as well as existing product offerings, and yeah, we are certified HIPAA compliant as well.
Perfect. I have an audio data question here from Andreas. I'm sorry if I'm not pronouncing that correctly. They ask, is it able to analyze sounds with the frequency, pitch, contour, and other details that can be beneficial for a phonetician, for example?
Yeah, one of the primary roadmap items is basically making this platform fully multimodal. So we have strong image support. We're working on audio and video cases as well. So that's a great use case for this for audio. So short answer is that that's all in the pipeline. And yeah, if you have data that you're interested in working with on a design partnership with us, yeah, please do reach out, and we're happy to work with people on whatever kind of data from whatever kind of source.
All right, last question I see here. Again, if you have questions, drop them in. I'll also have another question for you myself, Dylan. But last question here I see is, how does it handle hallucinations? If there are there hallucinations generated by the models that we're using, for example?
Yeah, that's a great question as well. There's so the approach of basically extracting data and feeding that directly into the model is a big mitigation to hallucinations. It's generally not an issue with this product, purely because you're kind of constraining the data that the model is looking at by virtue of either using the documents itself, so you can do a basic kind of RAG, or extracting information and then passing that extracted data into the model is a very big part of mitigating hallucinations. And yeah, it's not really a problem we see in the product because of that.
Yeah, great. Cool. Question from me is, in terms of like what kind of scale Restructured can handle, are there limitations? What does that look like? What is Restructured able to handle?
Yeah, so for price and structure, obviously the data volume will have some dependency on that, but you know, tens of thousands, hundreds of thousands of data points can work totally fine. Like I said, we're fully building out multimodal support for large videos, large images, et cetera, like that. So um, I would consider it a challenge to see what scale we can get up to, but huge data volumes, especially inside pipelines that can just be run automatically in the background. Uh, that's something the platform can handle.
We just got a new question from Chris Martin. He asks, how well does it handle Excel documents?
Yeah, Excel documents would behave very well. We can basically take the document itself, because it's already has some structure to it, and directly import it. That's basically happens for free. And extractions can be performed by you think basically of Restructured as it's like Excel on steroids. You can aggregate columns with LLMs, and so you can directly import them, or you could convert the entire body of the Excel document if you had a whole bunch of Excel spreadsheets that you wanted to aggregate together. There's also the ability to basically convert them all to text and then do aggregations on the entire spreadsheet or a set of spreadsheets as well.
Oh, I like that. I like that description, Excel on steroids. It's cool. Great. We have a little bit more time. Dylan, I'm wondering if there's another use case that you might want to show. I don't know if there's another data set that you have ready or not, but if you do, maybe just showing another couple examples of something that you've looked at, something that you played around with, some interesting queries, just to give people a little bit more sense of what's possible. And again, it's the huge variety of use cases here. We only had a chance to show really one or maybe two, but there's a lot more that we can show here. So just curious if anything is prepared for you. And if not, then just let me know.
Yeah, let's maybe take one look at a use case we didn't touch on in the webinar, which is summarization for really long content, because that might be of interest to people. Okay, I'll share my screen again. So yeah, for this example, let's take a look at transcript data from public company investor calls. So I'm going to make a new data set, and I'm just going to grab a few of these transcripts. So in this case, it's from a set of retailers. So let's just go ahead and grab, let's say, 4 transcripts and start importing those documents. And so the documents themselves, they're basically from quarterly investor calls that public companies are required to report. And if we look at the contents of these documents, there's sort of about 20 pages-ish of content that go through different updates for the business. And in this case, I've got 2 companies here, transcripts, and I'm looking at companies in the home improvement space. So if we run, we can do the same sort of basic extractions on the text here. And even though it's quite long, we can basically identify the relevant parts when we do an extraction. But we might also want to do a summarization just to get basically all mentions of a topic. So let's do that for, I don't know, let's do shareholder buybacks, for instance, because that might be mentioned in these documents. So when we do summarizations, you can provide keywords to focus on, or you can just let Restructured summarize the entire document. You can also adjust the relative length of the summary. So if you're looking for something, as detailed as possible, you can choose that. Or if you're looking for like the single sentence, that works as well. And so yeah, it's going to basically do a rolling window summarization. And in this case, you can see it's pretty quickly generated some summaries for all 4 of these documents on all references to that topic. And this can be really useful if you have a huge volume of data. Like some of the data we've looked at is like congressional bills that have like 400 pages of very dense PDF. And summarization can be a great technique if you are looking to do an extraction for a specific value and the document is humongous. And so it's useful to do the summarization sort of as an intermediate step so that you can kind of verify that your result looks correct and then perform the final extraction afterwards. But yeah, you can see in here, it's extracted, a medium summary of just 5 bullet points that mention specific items about that topic in these documents.
Awesome. Thanks for sharing that. Got a couple more questions while you were demoing there. First one, is it possible to manage and utilize data within a controlled walled garden environment?
Yeah. So we kind of have a range of deployment options. The kind of ranges from fully cloud hosted that you receive latest updates deployed on our cloud. The data is still encrypted and everything, but it is deployed all the way to something that basically we can provide you a container that you can run locally, and you could even opt in to only use local models, so that we would basically select models that can run locally that we think will be the best performing, and it might not perform as well as state-of-art models that are only available through cloud providers, but we do have that option such that your data would never leave the premises at all. And for a lot of use cases, the performance of those models is totally acceptable and still very useful for specific use cases.
Next question is, this is related to the demo that you were just showing. I think it says, Shefali says, the length for the summary can go up to how many words max?
For summarization, there's no limit. The longer it is, the longer the summarization will take. But the technique basically breaks down the document into chunks to do summarization in kind of a rolling update. And so there's technically no limitation to how long of a document you could summarize.
Yeah, gets back to that infinite context potential, which is very cool. Speaking of cool things, this might be our last question here. This is just for you, your opinion, Dylan. What's one of the coolest things that you've been able to do or that you've seen while you've been playing around with the tool?
I think I'm just surprised that the scale that and the kind of like interactivity you can have with a tool like this kind of took me aback compared to when we started looking at this tool many months ago. A lot of, like I mentioned in one slide, a lot of technology has just been released in the last few months that's really made this possible. But it's pretty amazing that you can run thousands of these extractions at once on these models and see results in real time, and generate code that actually executes and queries that execute. So I'm just kind of amazed at how you can take these little pieces that work really well with LLMs and stitch them together to do something that feels a little bit magical.
Yeah, magical is exactly what I was going to say. I'm playing around with it myself. It just feels so seamless and easy. And yeah, magical is definitely the word I would have used. Cool. All right, well, we'll go ahead and wrap up here. If we didn't happen to get your question for whatever reason, feel free to reach out to me directly. Here's my email address. It's just skip@kolena.com. And again, if you want to try this out, you want to talk to us about it, you can email us at restructured@kolena.com. You can also see our product page for this on our website here, or use this QR code to get linked directly to the beta access form, which I also dropped in the Zoom chat. And then if you're curious just about more ML best practices, AI quality education, that's what Kolena is all about. We have a lot of great content on our blog. And again, check out AIQCon on YouTube for a lot of great talks on AI quality. All right, well, thank you all for joining us today. We'll look forward to seeing you for the next talk. Have a good one. Thanks, Dylan.
Thank you.